Okay. Hello everyone. So, yeah, mm, first of all, I guess a basic introduction is required or needed. So, my name is Satyam Bansal, and I'm a software developer with about 8 years of experience in writing web applications with TypeScript, React, and JavaScript. About 2 and 3 years back, I fell into this, blockchain rabbit hole, and yeah, since then, I worked on a couple of good blockchain projects, including Passage Protocol, which is platform for generating dynamic member NFTs. I worked with Degen Ape Academy in the Solana ecosystem, but amazing guys. So yeah, and yeah, currently I am on my journey to learn Starknet, and I am part of their Basecamp 7 cohort. So I thought maybe the better and effective way to learn is to learn in public. So that is the whole reason of starting this stream. So, uh, the main idea is basically, to talk out loud to myself, and basically, what I am learning, and hopefully to connect with like-minded people who are, doing the same thing. So that's it. I mean, I guess it's not correct to say this is a day one because I've already done pretty much good amount of work. So I'll just, uh, walk you through what I have done so far, and then we can, move forward. So, so what I have done so far is done the basic setup for Cairo. So first of all, if I try to, just frame out like, take a step back and discuss what is Cairo. Okay. So I would say like, Cairo is a programming language, programming language to develop smart smart contracts. But I guess that is not exactly, the complete truth. Cairo is a programming language to develop provable programs, or I can say Cairo is a programming language to develop provable programs. Provable programs. Okay. So I guess the next question is like, what is this thing called provable programs? What is this thing? What is this thing called provable programs? I guess this requires a bit of understanding about the concepts, computer science concepts. I mean, you need to be with me to understand this. It's now not going to be easy. So first of all, this thing called provable programs, it's related to what all we know. It's related to zero knowledge proofs. Okay, zero knowledge proofs. Okay, and most of most of the applications of most applications of provable programs are in blockchain domain, at least right now, at least right now. Okay, so there is that. Now, okay, so basically, what kind of problem provable programs is solving, or Cairo is solving, or on the bigger picture, the Starknet is solving, right? So if you are aware of the, you know, blockchain, concepts of blockchain, or familiar with the blockchain ecosystem, right? If you are aware of the blockchain's fundamentals, mentals, if you have a basic idea about how blockchain works, you know, couple of things, right? Couple of things. uh so I guess, basically, what what I guess will make sense is, like, just to talk right now. Okay, so idea is like, what I say. Okay, Ethereum, right? Ethereum is one of the, most popular blockchain because of its because it's configurable, and Ethereum supports, basically, programs written in, you know Solidity, which is a Turing complete language. So basically, it's an operating system, right? It's an operating system. So, couple of things. Okay, let's delete this. Okay, first of all, Ethereum is ETHERE. Ethereum is one of the, I don't know why Ethereum. Okay, one of the popular blockchain. Okay, in Ethereum, you develop. Ethereum is basically what Ethereum is basically is, you have lot of nodes, you know, lot of nodes, or what do you call, say, validators, right? And if somebody sends a transaction, that transaction gets executed at all the nodes, right? And Solidity is a programming language for developing programs. Solidity is a programming language which can be used to develop programs that can be deployed on Ethereum, right? Solidity is a programming language which can be used to develop programs that can be deployed on Ethereum. Okay. Now, okay, so we are still very far from the we're still very far from this, this concept of, what do you call, say. So, okay, uh, basically, in it is a blockchain is a shared ledger, or sort of distributed database, right? Okay. Now, transactions are used to change blockchain state from A to B, right? Okay. Any transaction needs to be verified by verified verified by multiple validators in order to be in order to become part of chain, right? Now that is where need to pay users need to pay a gas fees for to get their transaction to basically execute when submitting the basically the idea is that submitting the transaction, right? So basically, we obviously, like, if you are with me, already all of this thing, right? So the idea is now like this is I have painted this picture with very broad strokes, right? Distributed, huh? Distributed, yeah. Hmm. So I have painted this picture with very, broad strokes. You Right now we don't have any idea, like, what this provable programming things can do. Now let's talk about roll-ups. Let's talk about talk about roll-ups. So bottleneck, one of the biggest bottleneck for Ethereum is scalability. Scalability, right? So that means as you get billions of transactions onto the blockchain, the chain, it starts to get clogged like a pipe, like a pipe, and per transaction, and gas fees also becomes very high. Gas fees also becomes very high, right? Okay. Now that is one of the main thing. Okay. So roll-ups are mechanisms where you don't execute every transaction, like nodes where chain nodes don't execute every transaction and have a hmm, it's the responsibility of executing the responsibility of responsibility of executing these transactions is of third party, and once and after executing mm, large number of transaction, it just sends the updated state to node, right? This is like more or less the thing that is going on. there are mainly there are mainly There are two kinds of rollup. For our importance, I don't know if there are many other kinds of rollup, but I know two. Optimistic, optimistic rollup, and zero knowledge. Zero knowledge rollup, right? Basically, I mean, what I would say is optimistic rollup is, some other parties taking 10,000 transactions and, executing all of those transactions and then basically generating this state after this, and you publish this, you get, you send this state to the main chain, and if there are like any issues, if somebody flags that those issues, that person, that particular, client gets reward. So it's sort of this reward incentive based, and then there is like, 7 days of block period or something. But yeah, but the whole point is like, optimistic rollups are not really that feasible. Yeah. But zero knowledge rollups, zero knowledge rollups are feasible. They don't rely on, any other party to find any wrongdoing. So yeah, it rely rather than it relies on math. So there is this concept of Stark. Let's talk about the zero knowledge. Let's talk about zero knowledge groups, rollups, let's say. So in zero knowledge, we generate a proof that says we have executed these transactions in a correct way, and then verifier verifies this proof, and verif if the proof is correct, the proof is correct, transaction becomes part of the main chain. Transactions become part of the main chain. So this is the idea of the, and Cairo is essentially a programming language with which you can develop a program for which a proof can be generated. And Cairo is essentially, so I guess, yeah, Cairo is essentially a programming language for which to write programs for which proofs can be generated. Okay, so now let's see. Okay, now let's see what to do next. What to do next? To do next is, okay, I'm going to take a break, a small break, then I'll be right back. Okay, guys. Yeah, I was just, checking, making sure if the stream looks good. So, okay. So, yeah, essentially, in a nutshell, the zero knowledge proof thing is what I say. Zero knowledge proof is essentially, way of proving to somebody that I know something without actually telling, without actually telling what I like, without actually telling that I know. Okay, so for example, like zero knowledge proof is uh, sort of proving to somebody somebody that I know something without actually showing, without actually revealing 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 the ans the knowledge, without actually revealing mm, revealing everything, without actually revealing everything. I guess the example will be very helpful. I guess the example will be very helpful. Be very helpful. So okay. So for example, like yeah. So yeah. Let screen share. Yeah. In the zero knowledge proof, there is a prover and there is a verifier. Okay. Okay. So now what next? What next we want to do? I guess the next thing that we want to do is next thing that we want to do is maybe start with the Cairo, right? Let's jump right into the Cairo thing and yeah, read out read it out loud. Yeah. First of all, to run Cairo programs. Wait a minute. Let's say Cairo. Okay, Cairo programs. Okay, first of all, to run Cairo programs, you need Rust installed on your machine. Okay, and after so Cairo syntax is similar to the Rust syntax, and I would say Cairo Cairo takes a lot of inspiration from the Rust, right? So yeah, if you are if you are familiar with the Rust, yeah, it will be very easy to get started with the Cairo. You also need this tool called Scrap. Need to install Scrap. Okay, and don't worry, like if you don't have any idea about how do I do this, so you can use this GitHub repository. If you can use the GitHub repository to find out the instructions on how to do this, right? So yeah. Okay, now uh what next is the running a example Cairo program, maybe. Yeah, so let's run the example Cairo program. So we are going to make a new project. Scrap new my first hello Cairo program. Hello world. ah Scarf. Yeah, command is wrong. Scarf new hello world. Okay, cd hello world. Well, you should be able to see this. Let's see. Well, you can also install the Cairo extension, VSCODE extension, to get the all of those things right, like syntax highlighting and all that sort of things. Okay, so I guess we have a program. In this, we have a Fibonacci series. So what we can do is, let's say, I guess we do use it if I want to print something, debug print rate. I'm not sure if that is the correct syntax, but let's say let z equals to 3 dot print. Okay, let's see. So to run this, we first need to build the project. Ah, I am missing the semicolon. Nice. Okay, and इसका Cairo run, correct? Okay. Fibonacci series is using loop, and we need to use the available gas. So I'll tell you about this in a minute. Just yeah. So basically, and the outputs are always in the hexadecimal, and that's what Cairo supports right now for the debug. So if you need to convert them, you can use ChatGPT, right? So yeah. Okay, so yeah, available gas thing, right? So as you know, these programs are going to execute on a Cairo VM, Cairo virtual machine, and if the loop condition is infinite, we are using resources endlessly, so we need this loop break condition, fail safe condition. So if the loops goes wrong, uh, so that fail safe condition is available gas. So if the gas goes out, the program halts immediately. So yeah, that's about the loop break condition. Okay, so now obviously, most of if you are familiar with the Rust, the syntax might seem well familiar to you. Like, we use let for the variable declaration, mute is for so variables in Rust, or what I say, variable in Cairo are immutable by default. So if you want to make a variable mutable, you have to add a mute keyword. Then the if condition, else condition, it remains same. The other interesting thing is this data type of field element. Field element is something that is very new to, that is like specific to Cairo thing. Like, the way this Proval programs work. Field element is sort of, is very, number is between 0 and very large prime number, which is really large, like 2 to the power 71 or something, I don't know. So yeah, I mean, you can read more about field element in the, you know, yeah, on the Google. But I guess, yeah, I'm tired now. So we will continue with this stream maybe tomorrow. So today, just to recap, what we have got is, like the basics of, like, just the basic map of what we are trying to build, that sort of thing. But yeah, that's pretty much it.